Now in this lecture, I am going to explain to you the algorithm that will be used to delete an element from a queue. I have showed you how we people can insert as well as delete elements in a queue. And in that case, I have told you when the value of front is equal to 0, or we can say front is equal to null, that means our queue is empty. So let's dive into the algorithm. See, the first thing I will have to do is I will have to check whether there is an underflow error. And as we know, if value of front is equal to 0, that means there is not even a single element in the queue. So I am making the first check. If front is equal to 0, then I would display the message queue underflow error, and the control will return to the calling algorithm. Right. Okay. So if value of front is not equal to 0, that means there is a surety that there is at least, if not more than one, at least one element in the queue. So in the second step, what I am going to do is I am just going to extract the element which is in the front and put it into the variable val, because of course our purpose of extracting an element, that is deleting an element from a queue, is just to use it somewhere in the logic, in some other part of the algorithm something. So what I am doing is queue front, that is the element which is at the front will be put into the variable val, or name of the variable could be anything. Now we go to step number 3. In step number 3, what I am doing is I'm making the check if the value of front is equal to rear. Right. Always remember, I have told you this earlier also, when the value of front and value of rear is equal, that is a clear-cut indication that our queue is having only and only one element. So that means if this condition is true, that means there was only one element in the queue, and that has been extracted, that has been deleted. So what I'm going to do is I'm going to assign the value 0 both to the variable rear as well as front. That indicates that now queue is empty, right? And instead of 0, I can also alternatively I can also use a null also, like in the first step also I have given the comment 0 can be replaced by null. Okay, else means this condition is false. That means front is not equal to rear. That means there are more than one elements left in the queue. So now what I am going to do is I am making the check if front is equal to n. That means if the value of front is equal to the size of the array, n has been assumed to be the size of the array. Of course, then we will move towards the first element of our queue, and we will be assigning the value of front as 1, right? And else means this is a normal case, and we are neither the value of front is equal to rear nor the value of front is equal to n. That means it is a normal case, and value of front is anywhere in the middle of the queue. So we would be simply incrementing the value of front by 1, and after that the control will return to the calling algorithm.